Suppose x is a normally distributed random variable. Mean 12, standard deviation 2.5. Find each probability below. So A, we have the probability that x is less than 9. What we're going to do is incorporate a few things from the last section. First, we always begin by drawing. Second, we convert x values into z values. And we had a formula for that in the last section, convert to z, and we used the formula z equals x minus mu over standard deviation. After we do that, we can look up our probability using the z table. So let's take a look at A, the probability that x is less than 9. So we'll start by drawing this distribution. So remember, x is normally distributed, has a mean of 12. 9 is less than, so to the left of 12. We want all the probability of x being less than that 9, so to the left of 9. Shade that tail, and our drawing is complete. Next, convert to z. We already know the mean of the z values is 0. We just have to convert the 9. So using our formula, it's 9 minus the 12 divided by 2.5. And if we crunch that through on our calculator, we get negative 3 over 2.5, which turns out to be negative 1.2. Last but not least, let's look this up on our z table, and that will be the probability that x is less than 9, which equals the probability that z is less than negative 1.2. So let's look up negative 1.2 on our z table and see what we get. Scrolling down a little bit, we find negative 1.2. 0 is in the first column, and so our answer is 0.1151. The same process applies for parts B and for part C. So let's do B next. Again, we begin by drawing. Here's our normal distribution. Again, the mean is 12 for x. We're looking for the probabilities of x being between 10 and 11, which are both to the left of 12. So we draw a vertical line above the 10 and 11, and we want to find the area and hence the probability between those two numbers. So we have to convert each of these guys into z-scores, and so we do 10 minus 12 divided by 2.5, and we also do 11 minus 12 divided by 2.5. And that's going to convert to z for us. We already know that the 12 becomes a 0 because 0 is the mean. And crunching these through on our calculator, I come up with negative 2 over 2.5 is negative 0.8, and negative 1 over 2.5 is a negative 0.4. So next we can use the z table to find our probability. In other words, the probability that x is between 10 and 11, and that's just exactly how I think about it. X is between 10 and 11 is equal to the probability that z is between minus 0.8 and minus 0.4. So recall how we did this. We look up the larger number, which is actually minus 0.4 first, and subtract off the smaller number. So we have to do the z table first, so let's start with a minus 0.4. Scrolling down a little bit. Minus 0.4, again, this one happens to be a 0, so we're going to stay in that first column, is 0.3446, or 0.3446. And then we have to look up the probability corresponding to negative 0.8. And notice that should be less because it's a smaller tail, and we'll subtract. So looking up minus 0.8 on our z table, scrolling down just a bit, minus 0.8 is also in that first column because it's minus 0.80 is the hundredths place. And so we end up with 0.2115. Just make sure of that. Oh, 0.2119. Okay, and we'll subtract off that value, 0.2119. And when we run to our calculator and we subtract, we get our answer. 0.3446 minus 0.2119 gives us our probability, and I come up with 0.1327. Last but not least, part C. Let's find a probability where x is greater than a number, in this case 14.5. So again, start off by drawing. And I recommend drawing just for partial credit on exams and things like that. 12 is in the middle. 14.5 this time is to the right. Convert to z. 12, of course, becomes 0. You don't have to write the 12 becoming 0. I like to, though. It helps me to make sense of things. And 14.5 is going to be 14.5 minus 12 over 2.5, the standard deviation, which is 2.5 over itself, which is just 1. And again, in this problem, we're looking for probability x is greater than 14.5, so it's to the right. So all we need to do is look up this value on our z table, and we have our answer. Probability x is greater than 14.5 is equal to the probability that z is greater than 1. Since this is a greater than problem, remember guys, we subtract from 1 and use our complement rule because the table always gives us left tails. So it's 1 minus whatever the probability is when we look up the z value of 1.00. It's not 1 minus 1, which is 0. We have to, again, go to the z table, make this a probability first, then subtract, and we have our answer. So go into our z table, we look up 1.00, positive, and that's right here, 0.8413, and again, we're sticking to the first column just in these exercises, and we get 0.8413. Okay, subtract that off. From 1 minus 0.8413, and I come up with an answer of 0.1587.